Welcome to our channel. So today we'll be discussing about method of visualization used in thin lead chromatography. This is the most important topic of TLC because these methods help us to identify which components are present in our mixture. So how does this method of visualization work? First, I will give you a background so that you will be able to understand why there are different methods of visualization used in TLC. So here is a TLC plate and it doesn't appear to be the same at the start of the experiment. So before the start of the experiment, it will appear like this when there's a plain plate, TLC plate. So like you can place the sample over here, a different sample, and then you have to place it into the solvent. The solvent rises up into the TLC plate, and after that you have to dry the TLC plate, this one, and you see nothing on the TLC plate. So how can you identify like different compounds on the TLC? So then comes the method of visualization. So we have to use different method of visualization to check which components are present in our TLC plate. So the most common method that are used in TLC are UV visualization, iodine spray, and acid spray. So what is UV visualization? See, that's our TLC plate, and you can, when we start the experiment, uh, when you place it into the solvent rise and you dry the TLC plate, you can see nothing on the TLC plate. Then you place it into the UV spectrophotometer and you will see different spots. There's certain limitation of the UV visualization as well. So which compound appear in the UV visualization? The compounds or the UV visualization commonly detect compounds that are aromatic, that are conjugated double bond, that contain conjugated double bonds. Conjugated means they have one double bond, one single bond, then one double bond, one single bond. That's called the conjugated double bond. Are the molecule containing chromophore, and chromophore is a chemical that can absorb the light and appears as a colored compound. So if our compound or if our mixture here doesn't contain any aromatic compound, any conjugated double bond, or it doesn't contain chromophore, then it will not appear in UV visualization. So we are unable to detect that compound. So the alternative method that we can use is iodine spray. So iodine spray is basically this an iodine spray. So you can see that these spots that I have marked with the lead pencil, these appeared on the UV when we use the UV spectra. These spots appear, and it only visible when you use the UV spectrophotometer. So after that, we use the iodine spray. Iodine spray, we can place it into the iodine bath, the container containing the iodine spray, and it sprays on the TLC plate, and the compounds appear as a brown spot with the iodine spray. And iodine form a weak van der Waals forces with the compounds that are present in the TLC plate, and we can easily detect those compounds using the iodine spray. Then there are some compounds that are not even visible using the iodine spray. So while performing the experiment, you will take two plates. One is, and you can analyze both of these plates with UV spectrophotometer, but one of the plate is then sprayed with iodine and one is sprayed with like acid spray. So if the compound doesn't appear in the iodine spray, then we have to use the acid spray. And the most commonly used acid spray is phosphomolebitic acid spray. That's a phosphomolebitic acid spray. You spray it under the TLC plate and you dry it. You can see the different spot. These are the blue spots that appear. It's the most commonly used like the compounds that are containing hydroxyl group. So you have to use phospho molebitic acid spray. This called the PMA. And then the spots appears like the blue spots, and you can check the distance travel by these spots, and you can then analyze, do the calculations and all the things. But these are the common methods that are being used to visualize TLC. So if you have any question, you can ask in the comment section. That's it for the method of visualization used in thin layer chromatography.